Hi, everyone. Welcome to the channel. In today's video, we're diving into the fascinating world of electricity by exploring the four main electrical quantities: voltage, current, resistance, and power. These concepts are essential for understanding how electricity works, from the devices in your home to large electrical systems. If these terms have ever confused you, don't worry, by the end of this video, everything will be crystal clear. So stick around, hit the like button, and subscribe to the channel. Let's get started. Let's start with voltage, also known as electric potential. Voltage is like the force that pushes electrons through a circuit. Imagine a water hose. The voltage is the pressure that makes the water flow. 1. The unit of voltage is the volt, V, named after the Italian scientist Alessandro Volta. 2. Voltage comes from sources like batteries, power outlets, and generators. Why is voltage important? Voltage determines the energy available to move electrons through a circuit. The higher the voltage, the more energy there is to power devices. Practical example. A 1.5 volts battery powers small devices like remote controls. Meanwhile, the power outlets in your home provide 120 volts or 240 volts, depending on your country, which is enough for larger appliances like refrigerators and TVs. Next up is electric current, which represents the flow of electrons through a conductor, such as a copper wire. Returning to our water hose analogy, current is like the amount of water flowing through the hose. How is current measured? 1. The unit is the ampere, named after the physicist André-Marie Ampère. 2. Current can be direct, DC, where electrons flow in one direction, or alternating, AC, where they change direction periodically. Practical example. 1. In your smartphone, the battery produces direct current to power the device. 2. In your home, the electricity supplied by the grid is alternating current, which is ideal for transmitting power over long distances. Fun fact: electric current is what powers your devices. However, if the current is too high for a circuit, it can cause overheating or even fires. That's why we use fuses and circuit breakers for protection. Now let's talk about electrical resistance, which measures how much a material opposes the flow of current in a circuit. Think of the water hose again. Resistance is like pinching the hose, making it harder for the water to flow. How does it work? 1. Resistance depends on the material, length, and thickness of the conductor. 2. It's measured in ohms, omega, named after Georg Ohm, who formulated the famous Ohm's law. Ohm's law. The relationship between voltage, current, and resistance is given by the formula V equals R times I. This means voltage equals resistance times current. Practical example. In an electric shower, the resistance converts electrical energy into heat to warm the water. If the resistance is too low, the shower might overheat and burn out. Conductors versus insulators. 1. Metals like copper and aluminum have low resistance, allowing current to flow easily. 2. Materials like rubber and plastic have high resistance and are used as insulators to prevent electrical shocks. Finally, let's discuss electric power, which measures the amount of electrical energy consumed or produced by a device in a specific amount of time. Power tells us how much work is being done by electricity. How do we calculate it? The formula is straightforward. P equals V times I. This means power equals voltage times current. 1. Power is measured in watts, W, named after the inventor James Watt. Practical example. 1. A 10-watt light bulb uses very little energy and is efficient for lighting. 2. An electric shower might use 5,500 W because it needs a lot of energy to heat water. Why is this important? Knowing the power of a device helps you understand its energy consumption. That's why your electricity bill measures consumption in kilowatt hours, kWh, which indicates how much energy was used over time. Let's recap. 1. Voltage is the force that pushes electrons. 2. Current is the flow of electrons. 3. Resistance opposes the flow. 4. Power measures the energy used to do work. These quantities are at the core of everything electrical, from lighting a bulb to charging your phone. Now that you understand these concepts, you can even apply this knowledge to save energy at home. Did you enjoy this video? If so, leave a like, subscribe to the channel, and hit the notification bell to stay updated on more content like this. Share this video with your friends who want to learn about electricity. I'll see you in the next one. Take care.